All right, welcome everybody. I'm lucky that you get to hear me teach you over the computer now instead of just out in front of the classroom. And our first lesson is going to be on area of polygons. Two things that are important to know before you find area of polygons is what is the area and what exactly are polygons. So we'll go over both these things before we get to some examples. First thing you need to know is what area is. Area is just the number of square units that cover the surface of the closed figure. Basically, if we were to take these shapes and break them down by squares, it's how many squares there would be on the inside of the figure. So if you were to count all those individual squares inside of this rectangle, you would count that there are 45 squares inside of there. And that's all areas. It's just the amount of space inside of an object, and we have what are called formulas that help us to calculate this space. So before we get started, we'd like to go over some vocabulary. So if you need to, make sure you pause to write down the vocabulary in your notes. Our first word is a polygon, and a polygon is just any figure with at least 3 sides and angles. All of the shapes we've dealt with so far, squares, triangles, octagons, hexagons, whatever it is, they all have at least 3 sides and 3 angles, and that makes them polygons. Pretty much any shapes we're dealing with in the two-dimensional world are polygons. Next word is quadrilateral. Quadrilateral is just any 4-sided figure. So squares and rectangles, parallelograms would all be examples of quadrilaterals. A parallelogram is our next word, and a parallelogram is just a quadrilateral where the opposite sides are parallel. So for example, let me draw this down here at the bottom. If I had a shape that looked like this, where it's kind of just a square that's been kind of turned on its side a little bit, a parallelogram just means that the opposite sides, so this side and this side, are parallel, meaning they'll never touch no matter how far they run. And this side and this side are also parallel. So if I were to draw them out forever, they would never touch. Our next shape is a trapezoid. And instead of there being 2 sets of parallel lines, a trapezoid only has 1 set of parallel lines. For example, that would be a poorly drawn, but still example of a trapezoid where this side would be parallel to that side, but if I were to continue this side out and keep drawing it and this side out and keep drawing it, eventually they would meet here at a point, so they're not parallel. So that's a trapezoid, and the last shape, the last word, is area, and area is just the amount of space inside of a 2-dimensional object. So the area would be all of this on the inside or all of this on the inside of the trapezoid. So like I said, make sure you have these definitions written down. Don't go on to the next slide until you have them. And also at any point, you can pause the video, rewind, and see an example again if there's anything you're confused on. All right, so our first shape that we're going to find the area of is a parallelogram. And like I said, a parallelogram is just a shape where the opposite sides are parallel, so they never touch. We have a formula for finding the area of a parallelogram, and it says that the area of a parallelogram is the product of its base and its height. So we need to make sure we remember that product in math means multiplication. So what we really have is we have the formula area equals base times height. Base times height. And the reason why is if I were to take this little piece here, cut it off on the dotted line, and reattach it over here, I would just have a rectangle. So it follows the same rules as a rectangle where I multiply the one side length by the length of the bottom. In this case, we just call it the base and the height. So I find my missing information. I find out what my base is, or my B. I found out what my height is, or my H, and I plug them into my formula. So I have area equals, my base is this number right here. That's my 14. My height is this number. It's from the top of the parallelogram to the bottom of the parallelogram, and that is 6. And I need to remember when I have two numbers next to each other like I do here, without a sign in between them, that means I'm going to multiply. So what I'm really doing is 14 times 6. And when I do 14 times 6, I get 84. Now the last thing I have to remember is units, because in math, numbers are not important unless they have some unit attached to them or some meaning behind them. So in this case, my unit is centimeters, but because I am trying to figure out the number of squares that are inside of there, or the amount of space that's in there, we say it's not just 84 centimeters, we say it's 84 square centimeters. Make sure you do not forget that little exponent 2 that goes on top of your centimeters, because there's a difference between 84 centimeters and 84 square centimeters. So now that you've seen it, I want you to pause the video, take a few seconds, and try this one on your own. Then restart the video, and I will kind of go over how to solve this problem. So basically what we have here is we have another quadrilateral, we have another parallelogram, so it follows the same formula of our previous parallelogram, where we can just take the base and multiply it by the height. We do the same thing as in the last one, we just have different numbers this time. Okay, our base is 14, so we write that in for B, and our height is 7, so we write that in for H. And again, because there's no sign between the numbers, that means we multiply. So what we have is 14 times 7, which is 98 centimeters squared. Okay, this is definitely the most basic formula we're going to work with today. So if you understand that, you're ready to move on to the next one, which is area of trapezoid. So in area of trapezoids, we pretty much do the same thing. We just have a different formula that we have to follow. And the formula for a trapezoid is half of its height multiplied by the sum of the length of its two bases. And if you can see on the picture to the right of the definition, this is your base 1, this is your base 2, and sum means add, or the answer to an addition problem. So that means you're going to add the two bases together. And because that's in parentheses, we do that first. So for a trapezoid, we have area equals 1/2 height base 1 plus base 2. Let's take a look at the example of our trapezoid we have in the bottom right corner. First thing we need to do is plug in all of our information that we need. So we have the height, we can plug that in. That is, in this case, 16. We have base 1 is 17, and base 2 is 39. Doesn't matter what order you put them in, because you're just going to add them together anyway. So you could do 39 plus 17, or you could do 17 plus 39. All right, so order of operations tells us the first thing we're going to do is deal with what we have in parentheses. In parentheses, we have 17 plus 39. So I'm going to rewrite everything else and just deal with that 17 plus 39 first, which is 56. Now we have 1/2 times 16 times 56. It doesn't matter what order you multiply things in. So I could do half of 16 first, or I could do half of 56 first, or I could do 16 times 56 first. Whatever is easiest for you. So I'm going to take half of 56 first. So I still have my 16, I didn't do anything with that, but now I have 1/2 times 56. 1/2 times 56 is 28. Okay, so now what I am left with is 16 times 28, which after I do, I get 448. Again, my units this time is feet instead of centimeters, so I have feet squared. That's my answer. Okay, so it's basically the same thing. It's just being able to recognize what the different parts of the trapezoid are, which the base, which ones are the height, and then being able to do the math. So if you understand that, again, pause it, go on to the next problem, try it on your own before you watch me solve it. So in this case, what they do is they give us a word problem. They don't give us the actual picture of the trapezoid, but they do give us all the important information that we need. So it says another section of the deck is also shaped like a trapezoid. For this section, the length of one base is 27 feet, and the length of the other base is 34 feet. The height is 12 feet. What is the area of this section of deck? So they tell us it's in the shape of a trapezoid. So I'd like to draw it so I can see it first. It says the length of one base is 27 feet. So I'm going to write 27 feet. The length of the other base is 34 feet. And it says the height is 12 feet. So that's what we have. So then we just need to plug our information into our formula. Remember that our formula is area equals 1/2 the height times base 1 plus base 2. Okay, and then we just plug in our information that we have. Our height, we already know, is 12. Base 1 is 27. Base 2 is 34. And it doesn't matter whether, sorry, let me erase that. 27 plus 34. And it doesn't matter whether you're at 34 plus 27 or 27 plus 34. So then we solve 1/2 12 times 61. Okay, and whenever you get into a problem like this, the easiest thing would be to take the half of the even number first. So I'm going to do half of 12, which I know is 6 times 61. When I multiply those, I get 366 feet squared. Okay, so that's trapezoids. Our next shape we have is the area of a rhombus. Give me a second. So a rhombus is a four-sided figure where all the sides are the same length and the opposite sides are parallel. So it's a parallelogram, but it has one more rule that all the sides have to be the same length. So it's like a square where all the sides are the same, but it's like a parallelogram because it's kind of turned a little bit. It's not a perfect square. It's not all 90-degree angles. So the area of a rhombus is half the product of its two diagonals. Okay, we need to know what that means. So the diagonals are just from one corner across to the other is one diagonal. From the other corner across is the second diagonal. And I apologize for the poor writing there. So in order to find the area of a rhombus, we just do 1/2 diagonal 1 times diagonal 2. So let's look at our example. It says Jerry wants to make a kite like the one shown. How much fabric will he need to make his kite? Okay, so our formula is area equals 1/2 diagonal 1 diagonal 2. And it doesn't matter which one is diagonal 1 and which one is diagonal 2. So that means we have 1/2 diagonal 1 we could say is 15, and diagonal 2 we could say is 24. And then again, we're just multiplying. 1/2 times 15 times 24. It's always easier to take half of the even number first. So half of 24 is 12 multiplied by 15. And then we just need to find the product of 12 and 15. So we do 12 times 15, which ends up being 180 inches squared. Okay, so we just take our diagonals, diagonal 1 right here, diagonal 2 here, we multiply them, and then we take half of that answer. And that's how we find the area of a rhombus. So go ahead and try the next one on your turn. Be sure to pause the video, try it before you just see me do it. It really does help for you to try and figure it on your own. Again, write down the formula. That's our first step every time. So for a rhombus, our formula is area equals 1/2 diagonal 1 diagonal 2. And again, there's no signs in between any of them. That means we're doing multiplication for everything. Okay, so Diagonal 1, we call one of the sides. Let's do 16 is diagonal 1. Diagonal 2 is 9. And it, again, doesn't matter which one you call diagonal 1, which one you call diagonal 2, as long as you use each one of them. And then it's just multiplying. And again, we can multiply in any order we want, and we'll still get the same answer. So let's do half of 16 first, 1/2 times 16, which is 8. The 9 just comes down, and 8 times 9 is 72. So we have 72 meters squared for this rhombus. Okay, and the last shape we're going to deal with is a triangle. And a triangle, again, has its own individual formula. And it really will help in the future to kind of memorize these formulas, as they're formulas you're going to see in 7th grade and 8th grade, and again in high school. So for a triangle, the formula for area of a triangle is half the product of its base and its height. So like when we found the area of a parallelogram, we did base times height. The only difference is for a triangle, we're going to take half of it. Okay, so our formula is area equals 1/2 base times height. Again, the first thing I always do is write down my formula. Second thing I always do is just plug in my information. So if I look at this triangle, my base is 20. So it's 1/2, 20. My height is 8. So I write 8. And then I just multiply. So I have, again, I can do them in any order. I'm going to do half of 20 because I know that's really easy to do. Half of 20 is just 10. And then I bring down my 8 and I multiply 10 times 8 because I haven't multiplied with the 8 yet. And I get 10 times 8, which is 80 meters squared. So again, as you kind of start to do these a lot, they're very repetitive. As long as you know what information to plug in and you know what formula you're using, they're pretty easy to figure out. So go ahead and pause the video and try the next one on your own. Okay. This time the only difference is our base has a decimal. Don't panic. Do it the same way we've been doing. So the first thing we do is we write down our formula. Area equals 1/2 base times height. We plug in the information we know. So we know our base here is 8.5. We know our height here is 14. And then we just multiply. So we have, I like to always do half of the even number first. So half of 14, because it doesn't matter what order I multiply them. So half of 14 is 7. And then we do 7 times 8.5. Just to kind of jog our memory a bit when we're multiplying decimal, we multiply normally. So 7 times 5 is 35. 7 times 8 is 56, plus 3 is 59. And because we have one decimal point in our factors, we move it over one decimal point, put our decimal there, and our answer is 59.5 inches squared. Okay, again, if you know the formula, it's very easy to find the information you need, plug it into the formula, and just multiply. So to kind of wrap it up, our steps are always the same. The first step I always do when I am trying to find the area is I write down my formula. So we have our formula charts on our notes, but it's not something I want you to rely on. Make sure you kind of just learn them. And as you do them over and over again, you're going to get the idea of the formulas. Our second step is to then plug in our known information. Okay, plug in our, I'm going to write info instead of information, but plug in our heights, plug in our bases, plug in our diagonals, whatever that specific formula is asking for, plug it in. And then our last step is to multiply. In all of our formulas, it's all multiplication. The factors are next to each other. There's no signs. That tells me I'm going to multiply. And once again, doesn't matter what order I multiply them in. And once I multiply all those numbers together, what I'm left with is my area. Okay, and I need to remember that area is always in square units. Okay, I hoped this helps. I hope you get the notes. If you have any questions, please do not hesitate to ask me. That's it. I hope you enjoyed it.